Now, this is the 18th one. We are talking about exponential function. Exponential function. Exponential function. Like e to the power of x, a to the power of x. Now, this is e to the power of x. X is an example of a to the power of x, where e value is 2.712, something like that. Okay. So these type of functions are called exponential function. Let's rub this. Now let's come to the thing. Now let me write down y equal to fx is equal to a to the power of x. A can be anything. A is basically greater than 0. A is greater than 1. Let me take A first, greater than 1. Case 1. In this case 1. Case 1, that is A greater than 1. A greater than 1 in this case, if you want to draw, you will get like this. This is your x-axis. This is your y-axis. And this function will go at 0. Anything to the power of 0 is 1. So at 0 it will be 1. This point is x-axis is 0 and y-axis is 1. This is the graph of e to the power of x in this direction. In this direction, it is going up, e to the power of x. Now, so if you see this, now let's draw two, three graphs. 2 to the power of x, 2 to the power of x is less than 3 to the power of x, less than 4 to the power of x. For all x, this power x, for all x greater than 1. So let me draw the graph for this one. Then this will be like this. Like this. See, this is the graph of e to the 2 to the power of x. Now this will be the graph of 3 to the power. Let me take a different color. Wait. This will be the graph of 3 to the power of x. 3 to the power of x. Now let me take another color and draw the graph for 4 to the power of x. This is the way, 4 to the power of x. Now if this x is between this is 2 to the power of x is greater than 3 to the power of x greater than 4 to the power of x. If x is in between 0 and 1, what will be the change? Now see the change. What will happen? What will happen? You see the change. Let me draw the graph again here. Let me draw the graph here again. This is your x. This is your y. This is your 2 to the power of this is will be now 4 to the power of x. This one will be 4 to the power of x. Now this will be, this yellow color will be 2 to the power of x, and they will just reverse each other, and this will be this is 3 to the power of x. Sorry, this is 4 to the power of x, 3 to the power of x. Sorry, this is 3 to the power of x. Sorry, this is 3 to the power of x, 3 to the power of x, and this will be 2 to the power of 2 to the power of x. This will be 2 to the power of x this way. Wait a minute, it's a little clumsy. Wait, let me draw. Let me write 2 to the power of x. Let me draw it again. Wait. This was your x-axis. This was your e to the power of x, and now you will get 2 to the power of x. This is your 2 to the power of x, and this is your x-axis. This is your y-axis. This is your again y-axis, and this is your x-axis. Now, if the situation case number, this was case for case number 1. If we talk of case number 2, let us talk of case number 2. Case number 2. Case 2. For a greater than 0 and less than 1. At that case, y a to the power of x will be of the form, see, very simple. It will come from this direction. This is the point 0, 1, and this is your a to the power of x. Just the opposite. You can see everything will be opposite. Everything now will be opposite. Wait a minute. You can see this. In this graph, e to the power of x is in this direction, whereas in the below graph, it is in this direction. It is coming from, sorry, it's coming from this direction. It is going down from this side. This is the higher side. sorry, this is the higher side, this is the higher side, and this is the lower side. Now if you see this one, if you see this one, this is the higher side and this is the, sorry, wait a minute, this is the higher side and this is the lower side. This is what it is all about. Now exponential graph is over. We will come to see the log graph, the logarithm graph. This is 18, 19 and 20. So this is the 18 one. Now it's 20, 19th one. 19th graph. This is the 19th graph now. 19th graph. 19th graph is the logarithmic graph. Logarithmic graph. Logarithmic graph function, rather I call it log function. Log function. Now in this case, we have two situations again as we had in this case. We have two situations here. We have two situations, one for case 1, one for a greater than 1. For this, the graph would be like this. See, log is not defined for negative numbers, so this axis is of no use for me. Now, this is for a greater than 1. For a greater than 1, this is your function is like this. Fx is equal to log ax, base is a, and any number, and x has to be greater than, this x has to be greater than 0, has to be greater than 0, right? This x has to be, no, yes, it has to be greater than 0, exactly right. Now let us draw it. This is this way. This is the point 1 comma 0, 1 comma 0. This is the point 1 comma 0. Now we have the next case, case number 2. Case number 2, we have a between 0 and 1, y equal to log ax. We have this type of a graph. Of course, for this also x is defined for x greater than 0. Undoubtedly, we do not have negative side. Now the thing is going to be like this. This is your x-axis, this is your y-axis. Now it is going to be somewhat like this. It will, yes, this is your 1 comma 0. This is your 1 comma 0. You can see y is equal to a to the power of x and x is a to the power of y. Now I will show you how to get this. How to get this wait a minute, this complete thing, complete thing from here. Take log both sides. Log x is equal to log a to the power of y. Use the property of log, y log a. Now take this log underneath this. So you will have log x upon log a is equal to y. So again using the property of log, which I told you earlier, ax equal to y. Therefore, I hope you got this point. Now see some more important points in this. The point is here is if this log, now the important point is that I'm going to tell you right now. See, log ax is say greater than y, is greater than y, then x, that is this, then x is greater than a to the power of y, a to the power of y, a to the power of y, if a is greater than 1, and x is less than a to the power of y if a is less than 1 and greater than 0. Wait a minute. If a is if a is greater than 0 and less than 1. Similarly, if I this is the first part. Now I take you that I give you the second part. Wait a minute. Let me rub this line. Wait a minute. Yes. Now log ax is less than y, then x is less than a to the power of y if a is if a is greater than 1, a is greater than 1, and x is greater than a to the power of y if a is in between 0 and 1. Now this is, there are two more important relations. Let me say, this is the proof. I gave you the proof. of how you got. I gave, this is the proof. Wait, this is the, sorry. This is the proof. This is the proof of how you got from this, how you got this one. This is the proof of that. This is one more property of log. This is the another property of log, small, and I'll give you two more important properties, which I think I didn't give in the earlier video. Now here it is. You must note that a log, whatever it may be here, let's say m, whatever base, is equal to b log m a. This is another very important property needed in lot of calculations. This is a very important property you need to keep in mind. Now, one more property, log x, log, let's say ax, say log is greater than log az, 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 z. This is z. Then this implies two things. This x is greater than z. X is greater than z if a is greater than 1, and x is less than z. X is less than z if 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 a is between 0 and 1. Now one more property I'll tell you. This is third. Make it third. Make this one third, a very important one. Make this one fourth, and let's go for the next one. Wait a minute. Yes, we will go for the fifth one. Now the fifth one is a to the power of log, let's say a and x. It will give me x. This is another one. Keep these properties in your mind. Yes, one more thing. The domain and range of this thing. I think I forgot to give you the domain and range of two or four more functions. I'm here to give you that. The domain of the domain of log functions, domain of log functions are all r plus, that is not 0, other than 0. This r plus means all positive numbers, or that means all positive numbers greater than greater than 0 for log, and the range here in this case is complete r, that is from minus infinity to plus infinity. Similarly, I think you should try to know what is the range on domain of, I think, wait a minute, just a minute. Yes, of this log function I gave you, I can give you the of the exponential function, both the exponential functions. You can see the, if you see the, look at the graph, if you look at this graph and you look at this graph, this one graph, the domain is all r. The domain is always r, but the range, that is the y-axis, is from 0 to infinity. In this case also, it is, just a minute. In this case also, it is 0 to infinity. So let us write it down here. Domain is all r, the complete r, and the range in this case is 0 to infinity. This I think I forgot to tell you in my last video. I'm telling you now. Now similarly, if you look at this fractional part of the function, just a minute. If you see the fractional part of this function, see all values are in between 0 and 1. All values are in between 0 and 1. So in this case, I'll write here, whatever domain is all of r, but the range is 0 included, but 1 it never reaches. It never reaches 1. If you look at this graph, it never reaches this line 1, y equal to 1. So it's between 0 and 1 always. It could be 0.9 also. Let me tell you, just a minute. This one also. I didn't think I gave you. Yes. Here the range, the domain is complete in the ceiling function. See, the domain is everywhere. The domain is complete R. Domain is complete R. But what is its range? Integers. Just the integers. Domain, domain, domain in this case is R, and that is the real number, and the range is integers. The range is integers. Similarly, if you go, I didn't think, I don't think I gave you that also. I just gotta remember it. Like, let me tell you the domain and range of signum function. Yes, signum function. I gave you the domain and range. I gave you the domain and range of the ceiling function. Now for the floor function. Floor function also has the same domain. Domain is R and range is Z. Range is Z. That is integers. Now we will come to something very totally different thing. Now I'll tell you the structure and the equations of. I'm going to tell you the equations of first of circle in different cases. The circle in different cases. These equations, if you're aware of, it will be easier for you to understand the thing. Equation of a circle. Equation of circles. See, first case. For number one. Number one, if this is my circle whose center is 0, 0. This is of course x-axis. This is your y-axis. Center is 0, 0. Center is 0, 0. Then and the radius is r. Say a, whatever the radius may be. This is the radius a. Then x square plus y square equal to a square. This is the equation of a circle with center center 0, 0, radius a. That's all. Next one. I think this is which part of the thing I'm doing. Equations of circle. Let me. This is, I think. Wait a minute. Just a minute. Let me find out which number it is. Let me give you. Oh, wait. 19 and 20. This is 20th number. This is 19 and this is 20th. Yes, we are doing 20th. Now we are doing this 20th number. Now, the thing is this, we'll do the second equation of a circle. Suppose the equation is like this. Second, suppose the circle is like this. Circle is like this. Wait a minute. Your, this is, uh, this is, this is your x-axis, this is your y-axis, and it is going something like this. And the point is a comma b is the center. A comma b is the center, then the equation is x minus a square plus y minus b square is equal to r square, where x is, you can say a plus r cos theta, and y is b plus r sin theta. Do one thing, put the value of this here and put the value of this here. You will get sin square theta plus cos square theta equal to 1. You will get, because both r square will cancel both sides. With center is in this case, wait a minute. The center in this case is, the center in this case is, the center here is a comma b, and the radius is, radius in this case is r. Radius in this case is r. Now, the third general equation of a circle, third general equation you must know. Because at least when you will be doing calculus, finding derivatives in the chapter of implicit functions, then you will at least come to know what type of equation it is, whose equation it is. X square plus y square plus 2gx plus 2f. I'm giving you the standard equation of the circle is equal to, let's have this as a here, and a here. If you cross multiply, this whole will become a square outside. So let it be, let's remove these brackets. And this is equal to 0. So in this case, the center of the circle, you can convert this equation to, wait a minute, you can convert this equation to this equation also by expanding. By expanding this equation, you can convert this to this equation. Now see, the center of the circle is, center of the circle is, center is minus g by a. You divide this, you take this and divide by 2, minus half g by a minus f by a, and the radius is, the radius r is under root of g square by a square plus f square by a square minus c by a. And this is the radius of the circle provided g square plus f square, let's rewrite it, under root g square f square minus ac by a whole divided by, I've taken the a square out of the under root, provided, and this is a circle, provided g square f square is greater than ac. Otherwise, it is not a circle, that will become imaginary. This condition must be satisfied. G square plus f square should be greater than AC. Now, the diagram of the circle is somewhat like this. This is the point, center point. This is the center point minus G minus F. Don't think I've drawn in the first quadrant. That means it is negative. I have drawn it. I've written this minus G. Wait a minute. Let me make it big. See, I have written here minus G minus F. Don't think this is the first quadrant. That's why I've written minus. How can I write minus G minus F? It could be positive also. And if it is negative, it will shift here. If it is negative, it will shift here. But if G and F are negative, then this will become, it will be here. And the radius of the circle will be something, radius of the circle, let us say radius of the circle is R, and this R is this R. Fourth point, suppose this is the circle, and this is the diameter of the circle. This is the point x1, y1, and this is the point x2, y2. Then the equation of the circle is equation of circle is x minus x1, x minus x2. Let me write it here. Let me write this here. Wait a minute. Equation of circle is x minus x1 into x minus x2 plus y minus y1 and y minus y2 equal to 0. Convert this in this form, in this format. Multiply all this, multiply within this, and convert it into this format. And then you will be able to find the center and the radius. Now, next point is that we need to discuss is parabola. Parabola. The equation of the parabola is, we will take the first one. Y square is equal to 4ax. Now the equation of the circle, the figure is like this. This is my vertex 0, 0. Call the vertex, wait a minute. This is my vertex. This is my V. Vertex, this is 0, 0. And this is the way the parabola will go. This is the focus, a comma 0. This is the directrix. Directrix. This is x equal to minus a. X equal to minus a. Let me rewrite x equal to minus a is the directrix. This is the focus, and the line straight coming out of it is perpendicular to this line. This is called latus rectum. This is called latus rectum. And this is the first type of parabola. The second type is this. The second type, y square equal to minus 4ax. Here, this is, we will draw the line here. This is our vertex 0, 0, V, vertex 0, 0. This is the equation of the directrix. X equal to now a. This is the equation of directrix. This is our parabola. This is the way. Now the focus is minus a comma 0, and this is the latus rectum, as I told you. This is the latus rectum. This is a Greek, some Greek language, latus rectum. Now, this is what it is. This is the introduction to this another type of parabola, another type of parabola, third type. The third type. The third type is this way. This way. This equation is x square equal to 4ay. So basically, we went in the first and the third diagram. I was doing this type of equation. I hope you remember x square x to the power of 4. Only this x square is a parabola, not these. So I was drawing this parabola. I hope you have seen this diagram there in this is x square. This was a parabola basically. Now this is y equal to minus a, and this point is 0 comma a. This is the focus, and undoubtedly a line perpendicular to this is called the latus rectum. Latus rectum. Rectum, RECUM. This is the latus rectum. This is the equation of this parabola. This is the vertex. This is the vertex 0, 0. This is the vertex 0, 0. The fourth type. The fourth type is just the opposite of this. This is now the vertex. Coordinate is 0, 0. And you have the parabola going like this. This is now your focus, which has the point 0 comma minus a. 0 comma minus a. Let me rewrite. Let me rewrite the whole thing. Yes. This is the focus 0 comma minus a. 0 comma minus a. This is the focus. This is the directrix. This is the directrix now. This is the directrix. Y equal to a. Fifth, y minus k whole square is equal to 4a x minus h. Now in this case, this is your y-axis. This is your x-axis. Let me draw the line y equal to k here. This is our origin. Now let me draw the vertex to this parabola somewhere here. This is the point h comma 0. This is the point h. So this point becomes, the vertex becomes h comma k, because this point is the vertex and this becomes h comma k. Now our parabola would go like this. This will be our focus. That will be h plus a comma k, and the equation k, wait a minute, k, and this is going to be our directrix. This is going to be our directrix. This is going to be our directrix. This is the directrix. And this is x equal to h minus a. And now the next is our ellipse. The earth moves around the sun in elliptical orbit. That's why we need these type of equations. The first, x square by a square plus y square by b square equal to 1. It is this form. This is always in this form. Now, and where a square is greater than b square. This is known as the horizontal ellipse. This is the horizontal one. Horizontal one. This is like this. See, this is your y-axis. This is your x-axis. It moves in this fashion. This is your origin. This is your, there are two forces, AE comma 0. The other is minus AE comma 0. This point is A comma 0. This point is minus, sorry, just a minute. Let me rewrite it correctly. This point is minus A comma 0. I'm talking about this point. Now this point is A comma 0. This point is 0 comma B, and this point is 0 comma minus B. Now with this, Let me write down what is this is the focus. There are two foci basically, and E is the eccentricity. I'll write down everything. Center is center point. Center is 0, 0. You can see. Now the focus, because I'm using singular, AE plus minus, because this one is there and this one is there. Plus minus A comma this AE comma 0. The vertex of this ellipse, this is the vertex, this is the vertex, this V, and this is vertices, I should say vertices. This is the vertices. Wait, let me keep the picture. Yes, here it is. The vertices are plus minus A comma 0, plus A is here and minus A is here. Now eccentricity, E in this case is under root of 1, since A square is greater 1 minus B square by A square, since A square is greater than B square. This is in under root. Now there is the equation of the directrix. Directrix in this case, x is equal to plus minus a. 1 is from here, plus minus a by e. Let me draw it somewhere because I'm not getting, wait, let me rub this. Now let me draw it here. Let me draw it here. This is one line, x equal to minus a comma e. And let me rub this and extend this line. And let me draw the directrix here. X equal to plus a. Wait a minute. X equal to plus a by e. Now this is for the horizontal one. Now for the vertical one. Vertical. Second is this type of an equation. X square upon a square plus y square upon b square equal to 1. But here the case is a square is less than 1. So now the vertical ellipse will be something like this. Let me draw it here. This is your x-axis. This is your y-axis. Now this is this type of an ellipse. I get this type of an ellipse. Here it is one focus. The other foci is here. This is 0, 0 center. And this is the vertex V. This is the vertex V. The equation of the directrix is this. This is the directrix. Directrix. One is here. The other is here. Here it will be y equal to b by e. And here it will be y equal to minus b by e. The foci points. This point will be, say, 0 comma minus be. 0 comma minus be, and this point will be, this foci will be 0 comma plus be. That's right. This vertex point will be 0 comma b, and this vertex point will be 0 comma minus b. So let's write down everything. Center 0, 0, center 0, 0, vertices 0 plus minus b, foci, let's call it 4 because I'm writing for 1, 0 comma plus minus be. Then you have eccentricity in this case also. You have eccentricity E equal to, wait a minute, E equal to under root of 1 minus a square by b square, a square by b square in under root bracket, and the equation of directrix is y equal to plus minus b by e. Now the third is, what you need is the third one is also you can go for a general case like I went for a circle and a parabola. You can go for here also. Wait, let me draw it. Let me draw it here. This is the general case, that is x minus, this is the third case, x minus h. I'm drawing for the horizontal of the general case. Rest all remains the same, y minus k whole square upon a square upon b square equal to 1, a square greater than b square. Now you have your this y-axis, this is your x-axis, this is the line y equal to k, this is the line y equal to k, this small k I have taken. take this as small k. This is this point is, see, now this point, now this is our ellipse, something like that. Now my center of my ellipse is h comma k, h comma k. This is h comma k, and this point is a plus h comma k. This point is a minus h comma k. This point is h comma k plus b. This point is this point, vertex. Vertex is h comma k minus b, and the rest all are same. The eccentricity equation will be same, only the vertex and focus all will change. Now here it will not be AE. This only basic description you need, nothing more in this. I'm not going to teach you ellipse right now. Now let's go to hyperbola. Let's go to hyperbola. The next is hyperbola. Wait, let us draw this line. We have the hyperbola. Hyperbola. This is also a very, very important equation. This is of the form hyperbola. This is of the form like this. You can see x square by a square minus y square by b square equal to 1. Now this looks something like that. This is your y-axis. This is your x-axis. These are your directrix. One directrix here, one directrix here. There are two asymptotic lines y equal. This is y equal to minus x, and this is y equal to x line. And then you draw your parabola in this fashion. You draw actually two parabolas. Sorry, this line should not touch this. Wait, let me redraw it. It is somewhat like this, and this is somewhat like this. This is the point a comma 0 of the vertex. This is the point 0 comma minus a comma 0. Let me rewrite minus a comma 0 minus this point. This point is minus a comma 0. Here the focus is again, this is ae comma 0. Sorry, ae comma 0. ae comma 0. This is somewhat minus ae comma 0. This is x equal to minus a by e. Wait a minute, let me rewrite it correctly. I mean, clearly, x is equal to minus a by e. This is x is equal to plus a by e. That's all. These are your asymptote. T-O-T-E. This line will touch this curve at infinity. Similarly, this line will touch this curve at infinity. They will become parallel to each other, actually. Now, this is the horizontal hyperbola. Horizontal hyperbola. Horizontal hyperbola. In this case, this is the horizontal. In this case, center is as usual. This is the center. This is the center. Center is 0, 0. Focus is as usual. Focus is actually plus minus ae comma 0. The vertex is a comma plus minus a comma 0. Now here the eccentricity would be a little different. See, eccentricity e is equal to under root of 1 plus b square by a square. There was minus there. In ellipse it's minus, but in hyperbola it is plus. And directrix is as usual. Directrix is x equal to plus minus a by e. What changes is only here. The rest all remains almost the same. Similarly, for the vertical hyperbola, let us see. This equation is the vertical hyperbola. We have y square by b square minus x square by a square equal to 1. This will be like this. I'm not doing anything more in this. This looks like this. This is our x-axis. This is our y-axis. Now the asymptotes are like this only. Now you will draw in this manner. That's all. Nothing more. You don't need more than this. Now what you need is the next one, that is the rectangular hyperbola. The rectangular hyperbola, which is very important. Let us write it down. Rectangular hyperbola. Rectangular hyperbola. Hyperbola. This is something like this. Look, this looks somewhat like this. The equation becomes like this. See, you can see here that is x square. You can see in this is x square by a square and y square by b square. Both a and b will become same. Both a and b will become same. Here, x square minus y square equal to a square, and the figure is somewhat like this. These are your asymptotes, and only now you have this, and this hyperbola is, you can see this one. This one is also x square equal to y square is equal to c square. This is like you had this curve in the beginning. I told you it's y equal to this type of 1 upon x curve. This is the 1 upon x curve, which is symmetric about the first and the third quadrant.